Hey everyone, so let's discuss and explain the Doppler effect in the most simplified ways. So let's consider this is the source that is emitting the waves of sound or light. So when this source is at rest, the waves will look like this. Okay, so let's suppose when this source start moving in one direction, so the waves on one side will be of the higher frequency than the actual as compared to the other side. If that source is moving towards the observer, the frequency of the wave that is received by the observer will be greater than the actual. And if it is moving away from the observer, the frequency will be less than the actual frequency. Okay, so let's consider you are standing on a roadside and a car is going to cross you. So when the car is coming close to you, what you will observe a higher frequency sound, okay, that you will hear. And for the driver, the sound will remain same. He will not observe any difference. And when that car will cross you and it start moving away from you, what you will observe, a low frequency sound you will hear, right? But same for the driver, it will remain same. So this is the Doppler effect that we are going to discuss, and we will define it, and we will try to solve some past paper questions of this. So let's begin with that.
These are the objectives that we will try to cover today. These are from the A levels 9702 course of the Cambridge. Okay, so how we can define the Doppler effect properly? This frequency change due to the relative motion between a source of sound or light and an observer is known as the Doppler effect or the Doppler shift. Okay, so let's suppose this is the observer that is at rest, and when this observer is emitting the wave from it, it can be a sound wave or light wave, it will be perfectly synchronized with each other in a symmetrical manner. So it will be symmetrical rightward and leftward, and it will be distributed uniformly, right? But when this observer start moving in one direction, so what will happen, on one side the wave will broader and on one side the wave will go close together, right? So if the observer is at this point, it's receiving the wave from the source, so it will receive the more frequent wave. So frequency will increase for this observer. And if let's suppose the observer is standing at point P, so for this observer, the frequency will be decreased. Okay. So if the source is moving towards, the frequency increases, and if the source is moving away, let's suppose if you're standing at P, so frequency will be decreases. Okay, so simply that is the Doppler effect. It can be observed in the light, it can be observed in the sound waves. So what you will notice here, we will notice how the waves are closer together between the source and the observer compared to the point P and the source. Okay, on this side the waves are close, and on this side the waves are very far apart. If the observer was at point P instead, they would hear the sound at a lower frequency, and the frequency is increased when the source is moving towards the observer. Okay, and the frequency is decreased when the source is moving away from the observer. So let's try to attempt some recent past paper questions. Before solving the past paper question, we need to know this basic relation of the Doppler effect. It's explaining F naught is equals to Fs V over V plus Vs. What this F naught is, this is defining the observed frequency made in hertz, whereas Fs is defining the frequency of the source made in hertz as well. V is the velocity of the sound. Okay, it can be of the sound, it can be of the light, whatever the wave is, and Vs is the velocity of the source of sound or the wave or the light. Okay, again there is a plus minus sign if it depends on the object is moving away or towards the uh, observer. If the source is moving towards, the denominator will be V minus Vs, and if the source is moving away, the denominator will be V plus Vs. Okay, so let's start with the questions. The recent most question that we have is, an aircraft produces a sound of this much frequency. So this is the frequency produced by the aircraft. So this thing will be, for frequency we use F, and for the um, source frequency it is the S. Okay, and the speed of sound, this is given also. This is represented by V. The aircraft is directly in front of stationary observer and travel in a straight line towards or away. They are not giving us the information that is moving towards or away. Okay. The observer hears the sound from the aircraft at this. So this is the observed frequency. So if you notice in this question, what we are noticing, Fs is equals to 30, whereas F naught is equals to 20. So you can simply say that the source or the observer frequency is less than the source frequency. So it's moving away. Frequency is decreasing, it's mean that thing is moving away. So when it's moving away, we will use the formula F naught is equals to V, and in denominator there comes a positive sign, Vs, and there is a Fs. Now we just have to put the values. What we have to find what is the speed and the direction of the aircraft. So first thing, we know it's moving away, so it's A or C. We have to choose between them, and we have to find this thing. We have to find Vs. So to find Vs, first you need to rearrange this whole relation. So what we can do, we can bring this V plus Vs on left hand side, and V into Fs will remain there, and this V naught will go there divided. And now what you have to do, Vs will be equals to V into Fs divided by F naught minus V. Okay, now you just have to put the values. What we have, it is 330 into 30 divided by 20 minus 330, and doing the calculation you will get 165. It will be meter per second. Okay, so it's option C that is correct. Okay, let's move forward to the next question. What we have in this, a buzzer emitting a sound of frequency this. So this is the emitted by the source. So it is F for the frequency, and for the source we write S. Is attached to the string and rotated in a horizontal circle. The linear speed of the buzzer. So this is the speed of the source. V for the speed and S for the source. And this is the speed of the wave. It is V. And you have to tell maximum frequency of observed by the observer. Okay, so you have to find F naught. Okay, for F naught maximum, what we need to know, observer should be, source should move towards the observer, that is we know. So the relation will be F naught is equals to V divided by V minus Vs into Fs. So just putting the values, 340 divided by 340 minus 25 into 846, you will get 913.14 hertz. So that is option D. Okay, when you round this thing off, it will be 913. Okay, so let's move forward to the next question. A vehicle is moving with the speed of this. This is the speed of the source. That is the vehicle Vs directly towards the stationary observer. So it's moving towards the horn of the vehicle, emit a sound of frequency. This is Fs, and this is V, the speed of the wave. You have to tell the observed frequency. So they have already told you that it's moving towards, so it's pretty simple. You just have to apply the formula. F naught is equals to V divided by V minus Vs multiplied by Fs. Putting the values, 340 divided by 340 minus 30 into 440, that thing will give you 482.58, that is 483 hertz. Okay, option D. Okay, this is the last question. In this question, the diagram shows a car traveling at a constant speed in a straight line between person P and Q. The car sounded horn continuously as it traveled. The horn emits sound of the constant frequency. Which statement about the person? Okay, you need to understand the scenario. This car is moving towards the right side. So for Q, we can say for Q, it's moving towards. So it's moving towards, so frequency increases. Which frequency? F naught, observed frequency. For person P, you can say it's moving away. So frequency decrease. So now let's look at the option. In first option, the person P hears a sound of increasing frequency. No, it will be decrease. Person Q hears a sound of no. Q receives the higher frequency. No. Person Q always hear a sound of higher frequency. Then yes, this will receive higher. This will receive lower. So 3 is correct. So only 3 is correct. So it's option C. Okay. So that's all for today.